Next one is Enceladus, which goes around Saturn. This is my number 4. The thing you notice about Enceladus is what they call the tiger stripes. There's these great big long furrows on the surface. You notice it's smooth on one side and the other side is still all covered in craters. So there's like two types of surface on Enceladus. The smooth stuff with these cracks, and then the craters that looks more like a conventional sort of moon, what you expect. Like the other moons, it's also eccentric. There's a lot of eccentric moons out there. And it orbits just outside the rings, and sometimes it's much, much closer to Saturn than others. So it has the same effect. This moon has also been pumped. Nowhere near as much as Io, because Saturn is considerably smaller, much, much smaller planet.
So if you're like on the planet that's orbiting Saturn, you basically get stretched as well?
No, you won't feel it. You have to be the size of a planet or a moon to feel the effect. To a person it would be negligible. You wouldn't notice the thing. But these stresses in the moon, and it's mainly made of ice, which is hence the white colour, has created these huge cracks across the surface. And again, you can fairly quickly work out which cracks are older. These cracks have obviously been here for quite a while, and this is a more recent crack because it's run right across the top of these. We don't know how much older or younger they are. All you know is that these cracks were here first, and then this one came through. So these cracks were here, and then this one came through. And you can see there's very few craters there as well. So all this tension from the gravity is also helping to clear all the craters and breaking up the surface, and melting the ice and everything. This is an ultra high definition picture into some of those crevasses. You can see these tiny little dots. They're little rocks. They're about the size of a house. So they're still quite large, but you can see all these little rocks have all rolled down the hills, and they're all sitting down the bottom. Some of them are sitting on the side, but a lot of them are rolled down to the bottom of these little hills, the crevasses that are on the moon as well. So if you were on the surface, you would see these huge geysers of material that are coming up through these cracks. The material underneath, like Io, is being heated. It's mainly water, so it's being heated, and then it comes up through the cracks in the surface. Cassini, back in 2009, actually flew through one of these geysers as the material was coming up through the crack in Enceladus, and it looked back after it had gone through, and it could see this material was lit up. The sun was in behind it in the background, and it lit up all these sprays of water ice into space, coming up through some of those cracks. Enceladus, I'm going to have to ignore you. Right. Enceladus orbits inside a very, very faint ring, right, which is right on the outside. And you can see here, here's Enceladus. This very faint ring around here, and they think this material that Enceladus has pushed out into space is actually what's creating this very faint ring. So these geysers are shooting off, firing water and dust and other material into space, and it's held in the orbit around Saturn, and it's created this very, very faint ring. My number 3 is Iapetus, which I talked about earlier. It's interesting. Iapetus, as I said, it's on the inside of that Phoebe ring. Remember all that black material that was coming off Phoebe, and it's circulating around Saturn, slowly getting in closer, and then it comes to the orbit of the Iapetus. The interesting thing about Iapetus, when they discovered it, they could find it when it was on the west side of Saturn. And when it was on the east side of Saturn, they couldn't see it. And then it would come back onto the western side and they could see it again. And they thought, it must be white on one side and black on the other. That's why we can't see it when it's on one side, because the black side's facing, and when it's on the other side, the white side's facing. Which is exactly what it is. It's black on one side and it's white on the other. It also has a huge ridge around its centre. which stands about 13 kilometres high. So it actually looks something like that. So it's black on one side, white on the other, and it has a ridge around the middle of the dark part. So you can see it when it's on one side of Saturn. When it comes around Saturn on the other side, you can't see it because it's black.
Pitch black.
Pitch black, as dark as coal. There's a very large crater called Turgis. And the crater is 580 kilometres across. 1/3 of the size of the whole moon is one single crater. And you can see on this picture that it's white on one side and it's black on the other. And this black material they think is coming from Phoebe because that side goes through the inside of the Phoebe ring, picking up all this black material. So if we were to look at the orbit, again, it's what they call it's tidally locked. So the same part always faces Saturn. And as it orbits, the dark side leaves. So you've got all this material from Phoebe coming in slowly into Saturn from all around. And as it comes in, the Iapetus comes along and hits it on the surface, and all the black material deposits onto the surface of the Iapetus. And so the other side doesn't have this black material. Yes. And what actually happens is, if any material, white material, was to land on the black side, like ice, because it's black, it's warmer. So it will basically, it doesn't evaporate, it sublimates, but effectively it evaporates and it goes around to the white side where it's colder and it condenses. So the black part always stays black because if any ice deposits on it, it will make its own way back to the white side to keep the white side white and cool. And even when you look at it closely, it doesn't go from black to grey to white. It's either white or it's black. There is no grey shading. The material is either there or it's not there. Yeah.
So, what if where it joins up to the black and the white side? How would that stay?
It's sort of a mixture. When you get to the border line, it's little bits of black and little bits of white like this. So this is somewhere near the border where it's transitioning from white to black. So this is more on the white side, and then this is more on the black side. So, but the white is white and the black is black. There is no grey. So it's like a Collingwood football jumper. It's either a black stripe or it's a white stripe. There is no grey stripe. But when it's white, it's white, and when it's black, it's black.
So it just
stays that way.
So the moon itself just adapts both sides.
Yeah, it's just a natural. It's just a natural consequence of it always having the same face, and the dark side hitting this stuff that's coming from Phoebe, which is black. So it makes that bit black. And because it's black, if anything like ice lands on it, it's warmer, because black things are warmer, and the ice then evaporates and it floats around to the white side where it's colder and it condenses. So it's a self-sustaining thing. So because it started like that, it just sustains that, and it'll just keep doing that. It has been for probably billions of years.